What is a semigroup? The name itself is confusing and doesn't tell you much, but the underlying concept is incredibly simple and powerful. Moreover, I'm sure you already know it, but you don't realize it. It's one of those things that everyone understands, but no one can really articulate. You can think of it as an OOP pattern, like singleton or factory, though it's much more generic and simple. Let's start with the formal definition. A type A is a semigroup if it provides an associative function that lets you combine any two values of type A into one. Alright, hold on, what? It doesn't make lots of sense to me either. Let's break it down into pieces. First, a function that lets you combine any two values of type A into one. So, the signature is clear. It's a function with two params of type A. The result is of type A as well. Since it's a binary function, I'll use the circled plus sign to represent it. It will look like a binary operator, though you should remember that it's not a sum but an arbitrary function. Next, an associative function. What does this mean? Well, it means that if you have a long list of arguments, you can group them in any way you like, and the result stays the same. In other words, if you have an associative operation over type A, you have a semigroup. Now let's look at an example. The simplest and actually sort of useless example is a sum over integers. The sum of the integers is associative, so it's a semigroup. Another example is a list concatenation. However, the same type might have more than one operation to get a semigroup. For example, a product is also a semigroup over integers, just a different one. A slightly more generic use case for a semigroup is the reduce operation. This is exactly what a semigroup is for. It fits really nicely here. You can imagine it as squashing all the elements into one. Moreover, due to semigroups' associativity, reduce can be parallelized. You can split the input list into chunks and process each chunk on its own thread. Then apply the same function to the result of each chunk. This is how Apache Spark is able to handle enormous amounts of data. Why bother defining such a generic concept if it's only used for integer sums or a basic reduce operation? The semigroup reveals its true power when many kinds of semigroups are used together. Imagine that you have two arrays and you want to combine them into a new array, but you don't want to concatenate them, no. You want the elements with the same index to be combined in some way. But you don't want to define it yourself. You want it to be provided. So you actually want an array semigroup to depend on the semigroup of the type of the array's elements. This is where it really shines. You keep all the flexibility, but lift the decisions to the user. Another practical usage of semigroup is a map merge. The merge itself is not a problem. The problem is the collision. When both maps share the same key, you actually cannot resolve it, and the input is, you got it, a semigroup. Whenever there is a collision, you just combine those elements, that's it. You can define it in a generic way, so the merge function does not have to be specialized. It just consumes the semigroup for the map's values and executes it in case of a collision. That's it for semigroups. It's too simple to talk about it any longer. Thanks for watching. I hope you found it useful. Bye bye.